Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. It's time for us to do probably a little work with our, with the way we're working on entities right now. We sort of got movement into a place where it was kind of getting pretty interesting. And we want to kind of continue down that road, but in more of the entity system side of it. So today I think we're going to probably look a little more closely at how we're doing our entity type systems and start to think a little bit more about what that's going to mean as we go forward. So today is day 286. If you would like to follow along at home, you want to do day 285's source code. That's what I'm starting with today. So let's go ahead and boot up 4Coder here. And let's see, open our project. All right. So here we go. So essentially what we've got now, right? And I kind of played around with this in the Q&A because someone asked about it. We have the ability to sort of generate arbitrary additional little dudes here, right? And those are all full entities with the same motion controller and everything else as the hero and all that sort of stuff. And you can start to see, like, one of the things that I guess I should emphasize here is the way that engine development and game development does tend to work is it's very non-linear in that way. Like, you saw us spend a lot of time on, like, little detail things, several days, and, it's hours really, so, I don't know, think 2-3 days of coding, of full-time coding, let's say, we may have spent on just figuring out like how we were going to place points in the world and occupy them. We probably spent 5-6 full days of coding. If you took all those hours and put them in there, thinking about how we were going to do like entity storage and world storage, right? And in this course of Handmade Hero, which so far is only probably up to 6-7 weeks of total coding, if you pack the hours into regular work weeks. That's a huge amount of the project being spent on those things, right? But when you start to look at those, at some point they start to come together, and you can just do stuff like this, where now you've just got, stuff that sort of becomes an autonomous system, where it's like, oh, I just want more of these, and I threw them in there, and that sort of stuff. And that's sort of the curve that we're kind of going to see unfold probably over the next 100 coding days of Handmade Heroes, the next 100 hours or whatever, is things will start to ramp up quite a bit. And so you'll start to see things slowly get into that, because we're kind of like right at the cusp of that curve where all of a sudden it starts to shoot up, and adding things now no longer is just, oh, I did X amount of work for X amount of payback. It's like I did X amount of work for X squared amount of payback, and it starts to be kind of good, right? So that's really where we're starting to go, and I feel like being able to spawn people is kind of just a simple example of that, right? But we've still got a bunch of things. Like, for example, these guys are caught inside each other right now because we still have the old collision stuff, which doesn't really know what it's doing and isn't particularly logical for the stuff that we're working on right now. And we also have like a bunch of other stuff, like we need to figure out our Z stuff correctly. So there's a few things that we really have to go through before we're free and clear, but we're definitely starting to get there. So one of the things that I want to take a look at now is I want to start to get a little bit more of a sense of how the entity system comes together. And so what I'd like to do is start to try and break down some of these type-based operations that we're doing in the entity system. So in other words, right now what you see us doing in the entity system is we basically special case everything by the type of entity. So even, for example, the way that we know how to draw the little hero dude here, right, is because we created an entity that had a type of hero head and an entity that had a type of hero body, and those two things are used in multiple places to determine how it's controlled and how it moves. And that's not a bad thing. There are plenty of games whose entity systems work exactly that way, and that's not a problem. So, if you're doing it that way, that's great. And certain games where the entities are very specific, and each entity is supposed to be very unique and very different from all the other entities, that's totally the reasonable solution. It's just to write the code for each of the entities that you want, and off you go. And you can still share, like through functional decomposition, you can still share the things that they use. But in this game, we want a more of a continuous feel. Meaning, yes, we want lots of very different and interesting entities in the game, but we don't want those to be isolated points in space. We rather want the full concept of entities to encompass everything between those. So everything from, this hero through to a boss monster, rather than just having hero and boss monster, we want to be able to say, like, what's the thing that's halfway between the hero and the boss monster, or a quarter of the way between the hero and the boss monster, and that's right. We want to be able to sort of think about this sort of very, very varied space of like lots of different permutations that are scattered throughout the possibility space, so that the game has a lot of rich sort of texture to it in that gameplay sense. And again, this kind of comes more from, sort of the roguelike tradition of games, not the Zelda side, because, like I often say, it's sort of, we want to kind of combine those sorts of things. And that roguelike side is very much about not having all these hard-coded specific entities, but rather having hard-coded little chunks that assemble to create entities, so that they could be assembled in a different way to create a different entity, or removed from one entity to turn it into another entity, or added to an entity to give it that ability, right? And so that's what I wanted to start looking at today, just because I feel like now might be a good time to sort of play with that a little bit. I just get that sense. So what I want to do is take a look at this entity type field and start to think about, if we want to start to eliminate the actual use of this type field, what would we do? Right? So, for example, let's say we would now like to have some other entities in the game, which we want to completely reuse, for all intents and purposes, the code for our hero and make them. And those two entities, or a couple entities, are going to be an enemy whose movement, whose looks just like the hero. He's like the evil version of the hero. Looks and moves just like the hero, but he or she, whatever it is, the specter, it perhaps, the evil whatever manifestation of the hero, but it has some kind of an AI thing on it which causes it to jump around and attack the hero. So instead of using controller as an input, it uses some kind of artificial intelligence, or it just walks around. It doesn't even matter. Something that is not what that does not wait for keyboard input, right, to move around. Another one would be a floating head, and it uses the exact same code for the hero head, only there's no body. Another one would be just the body. Right? It hops around, but doesn't need a head to tell it where to do so, right? So even just with the code we have for the hero, which is very little code, right? It's like, 50 lines of code we wrote for that or something, 100 lines of code, I don't know how many, but very little. You can already see how, in theory, we could have created a number of entities. And if you start to think about different AI controls of them, you could have dozens of entities, like different head monsters, different whatever, that are all basically doing, that underlying code. But right now in our system, that would not be obvious how we would do that, right? We'd have to actually go in and change this to that. We couldn't just create one. And so what I want to look at in terms of pushing the system towards that more decoupled state where things are very pieced together, is what would I do to start getting me to a place where that would have just been trivial? And you can see that, hey, since entities just have all this information in them, we've already done the thing where we're just kind of doing the flat entity, and then we'll look at compressing it down later. We don't have a problem with the data. So creating the data for those other entity types that we want would be trivial, right? It just created an entity and it's already got, we know it has the data. So we don't run into any of the C++ nastiness of like having to like decouple class hierarchies, or oops, we did this wrong thing. It's like, we're not going to have any of that problem because the data is already flat. And so that'll just work no matter what combination of things we wanted to do, right? But this type field is still serving, this type field is still very much C++ object-oriented nastiness in a lot of ways, right? That type field is like saying this is a particular instance of this particular class of entity, which really prevents us from being able to do those mix-in things in exactly the same way that it is difficult in C++ to do them, right? And I shouldn't, obviously we're programming C++, so I guess I mean more the C++ class interface inheritance model, which I already said I don't like. So I don't want that. How do we get rid of that? Well, first things first. What I'd like to start by doing is saying, well, we know that this movement mode already exists in a sort of finite state machine, quote unquote, kind of a context where we have two types of movement that an entity could be doing: planted, where it's standing one place, or hopping, where it's going from one place to another via a hop. So the way in which you might be moving already has a state variable. So the fact that I have coupled that ability to use that state variable to the entity type is clearly a mistake, right? I could just not do that, and then all entities could have had a planted and hopping motion, and entities that want more motions can go in there, right? So that's the first way we can start to attack that entity type problem, is by saying, instead of having a type that says what type is the entity, let's focus on the parts we actually care about and make those have identifiers, right? So saying, what is the actual code differences that I actually care about at a lower level? Let's make those have them, and lo and behold, we already did that as part of the implementation. So really, this first part is just going to be an exercise in getting things off of the type variable when they didn't need to be there in the first place, right? So let's start by trying that, and we'll see what unfolds. So if I go into world mode here, and I take a look at the movement mode and where that's being used, and you know what, I'm going to go over here. I always forcoder starts you in this window, or rather my forcoder config starts you in this window. I probably should make it start in the other window for no reason other than, since this is a stream and my head is down in the lower right hand corner, it probably would make more sense to start so that I'm on the side that's not obscured. But anyway, so looking at the movement mode, we can kind of see here that there's a bunch of information that's going on and a bunch of things that are happening with the movement mode. What if we were to just pull those out so that they weren't actually in the inside the switch statement, right? Like doing the very most simple possible thing. Could I just move this out so that it wasn't in the switch at all, right? Could I do that? So let's start by trying that. And let's see here. We've got, what have we got here? T-thrust, this whole thing. So let's take a look at this whole thing here, the hero body code, right? You can see here that if the movement mode is planted, we pin it to its occupying square, right? We take a look at this head delta, and that head delta thing, that's obviously a little bit specific to paired entities, right? But the rest of this isn't so much, right? Like all of this, it's really just that bob amount that has to do with the head distance here. It looks like the T head distance. It's really just that bob amount that's happening inside planted. That's really it. And you can see that hopping in general doesn't really require the head at all. So I think what I'm going to start by doing, right, is I'm going to try to take this out and see if I can make this be its own sort of idea here. And if you're thinking in the back of your head, well, you know, this does look like the sort of thing, Casey, that you might want to pull out to a separate function. I agree with you, but not quite yet. It's a little bit premature to do so, so we're going to leave it inline for now, but you can see that that is kind of a thing that might be primed for pulling out into something, so it's easy to see what it, you know, it doesn't have to, it basically makes it easier to read. So I'm just going to make a note instead of making it a function for now, and I'm going to say, handle the entity's movement mode, and here we go with that. And then we're just going to go ahead and compile it and see what effectively our problems are, if you will. So down here you can see that we've kind of got this computation for T bob and DT bob and that sort of stuff. And so what I kind of want to do there is take that out and put it down in here, right? And what you can see with these equations, you're like, well, you know, everyone now is going to be using this DT bob. Well, maybe we're going to call that a slightly different thing that has to only do with movement. But even so, what we could do here is notice that we can have a DT bob which is like, you know, movement mode, you know, inert or immobile or something like this. And that could just not set anything, right? That could do nothing at all, if that makes sense. And so I could go into our entity structure. Let's go here, where we're sort of defining these movement modes. And I could make the default movement mode that you're just not doing anything at all, right? You're not bobbing, you're not stretching, you're not doing anything, you're just completely immobile. And so for something like a tree, which never does any moving, it doesn't even think about movement, it could have something like that, and wouldn't ever set DDT bob. Although now that I think about it, maybe I won't even do that and just say that that's planted for now. Because if you look at planted, it only was doing something when there was a head involved, and a tree would not have a corresponding entity that's like a linked part to it in any particular way. So it seems to me like that's probably okay, right? So let's just leave that out of the situation for now. So let's go ahead and rebuild. And you can see that our primary problem here again is that this part isn't really set up for working if there's no head. So let's not try to solve that just yet. Let's just go ahead and comment it out and make sure that we're okay when we run. Okay. So now you can see what we've done. Essentially, we have exactly the same code running. And we just don't have the extra bobbing motion that was happening before. But we have most of it, right? But when it's planted and you stretch, it doesn't go down, I think was the main thing. Based on it doesn't sort of hunch down. So really, we have lost nothing. And one of the nice things about this is it applies to all of the entities in the system with no deleterious effects, except for one, right? And of course, you may have missed it, but I'll show you again. This guy right here, you notice goes off into the middle of nowhere. Well, why is that? That's because the DT bob, like this whole equation, right, is entirely predicated on that DT bob, meaning sort of the springiness of the character's motion. And we were using that bobbing motion to actually control the floaty thing, right? It's got this entity, T bob here, right? So it's kind of getting added to the position using that increasing timing value. And so those two things kind of conflict, right? Now, I don't really know exactly how we want to proceed here. And the main reason for that is the floaty thing is kind of a one-off, and I don't really even know what it means or should be. So I don't have much of an opinion about what that really value, like what I want to do here, right? So, for now, we could even just say, let's not bother supporting this guy at the moment, and it's just another point temporarily. And we can sort of look at that in a second when we think about how we might want that to work in reality, right? But either way, you get the point, which is that we need to now make solid definitions for things. We don't want something called T-bob, because we don't really know what that actually ever means, right? We need to have solid definitions of our variables so that everyone can share them. And again, this is not a deficiency of the system, it's actually a strength. Meaning the goal of the system is to make single variable points inside the entity for single specific things of meaning so that everyone can share them and build richer interactions that build on top of them, right? And the example here is like if we have a value that's about how the bounce is happening, then other things can start to tie into that bounce value for other reasons. And that's what starts to make the entity system rich and create a variety of interactions that are interesting, which is what we want. Okay. So I'm going to put a to-do in here because I do want to think about this later. I just don't know what it means right now, but platforms, will want to sort of support. So think about what this stuff actually should mean, or does mean, or will mean, right? Okay. So now let's take a look at the more pressing problem, which is that these entities are paired, and there's this concept of the sort of, related entity, like an entity to which you are attached, if that makes sense, or that you're, I don't know what we'll call that. There's just this concept that entity can be paired, such as the head and the body, but you could imagine other things being like that. So, it's sort of a generic concept of I have an entity to whom I am paired, and I have a certain behavior towards that other entity to whom I am paired, and I want to, make sure that I support that, right? So what I think we want to do there is I think we want to sort of have a solid notion of what that means. So instead of calling this entity reference head, we'll call it something else. Now, what I want to do here, before we do anything else, is sort of start to create a section, or rather a partition, between these two. A partition where we start to move things up into the entity structure proper by saying, this is something we actually thought about, right? Versus this is some stuff that we just did while we were prototyping and getting things ready, right? And so up to this point, right, we've been basically trying things out and being exploratory, getting the engine running, doing whatever, software rendering, all these other things, right? Well, now we're starting to think about this entity system for real, and so now it's time to start saying, when are we going to actually lock down variables and say this variable means something and we thought about it? And I mean, it doesn't mean we can't change it, but there's a difference, right, between one of these and one of these other ones that we just kind of threw in there when we're just like playing around. So I'm going to start by saying the first one that we really mean, perhaps, is this one, entity reference. And the way that I think we might do this is to say, let's introduce a notion of almost like a geometry of these creatures, where you can perhaps have some child creatures and a parent creature, maybe. I mean, I don't know exactly how we want to do this, but let's just say that we're going to have some notion of this pairing, right? An n-way pairing. And I'm not sure how far we want to take that, but I'm just thinking of things like, let's say I have some kind of boss monster spider thing, and each of its legs is a separate piece that could detach and sort of like move around or whatever, right? There's sort of this maybe multiple entities kind of a thing going on there. So we're going to want something like that, and the head body case is a similar situation, right? The head is probably the primary concept of the entity, meaning that if you still have your head, you are still technically alive. I don't know, maybe that's not true. Maybe either or is alive, you're still technically alive. I'm not sure. But point being, you've got these entities and there's sort of this relationship between them, and I think we're going to see that a lot. And so we want some way of representing that relatively generically, right? We don't want to just say this is the head of the creature, this is the body. We want to say this is the parent entity, and the only question that I have right now is, do we want the notion of multiple paired entities? Because it seems to me like we're probably going to want the notion that I could be paired to multiple entities, not just a single entity, if that makes sense. So I think we would want to. And I think what we would want here is the concept that an entity can have some number of paired entities. So we would want something like this. Right? Where we sort of had the notion that there was some set of paired entities. We know how many there are, right? And we can sort of loop over them. Now, the thing that I'm not quite sure about, obviously, is I don't really know whether these paired entities have some kind of a structural thing going on, meaning, when I pair an entity with another entity, is there some kind of is there a meaning to that pairing? Because, maybe there's sort of, and the more I'm saying it seems like the answer is obviously yes, right? And so when I attach an entity to another one, maybe I just have this notion that they're paired, they're linked, would be one way of just describing it. And maybe like a parent to child link versus a child to parent link might be a thing. I don't know. But it seems to me like there's a little bit something going on there. And so, the notion of an entity reference could easily be expanded to have some kind of an enumerator with it that said, what kind of reference actually is this? Like, what are you trying to say my relationship to this other object actually is? And I don't know. Like I said, this is a little bit premature. But that's essentially what we want here. And we're going to want probably the ability to make these be as varied as possible. Meaning we'd like to know that the number of entities paired with a particular entity could be whatever it needs to be. And I would suspect that we probably want to have it so that it could grow dynamically. I'm guessing. That's my assumption. So we would want the ability for this entity reference set here to be as large as we want it to be, right? And if you want 12 paired entities or 23 paired entities or something like that, that's fine. So I don't want to implement anything with that yet because, like I said, I haven't thought through it enough. But I want to sort of have, I want to take that and now look and see what happens if I do, again, write the usage code first kind of a thing. What would happen if I was to say I can have multiple paired entities? So if I come here to say movement planted, and I know that I've got to, this was the code effectively that I wanted to write, how would I deal with this fact here? What would I do? And you can see that this code is essentially saying, however far away the head was from the body, I want that to be how far I crouch down, because I'm about to jump or something, right? And so if we wanted to maintain that behavior, let's say that we had multiple heads or something, right? What we would need to know there is what's the behavior supposed to be when we don't just have one. And there's a couple different ones we could do. We could look at the average distance away they are, right? We could look at the maximum distance away, so whichever one's the furthest. We could look at the minimum distance that one's away, right? Basically, we could use the set of norms. Norms are I don't even know why I'm bringing this up, but Handmade Hero, it's educational. It's supposed to be educational. So a norm is essentially like a measure. It's sort of a way of taking something and asking for a way of measuring it. And they often have names like the 1 norm, 2 norm, 3 norm, infinity norm, etc. And there's these are often the Euclidean ones we're talking about, right? So there's a bunch of terminologies here, like someone says the Euclidean infinity norm or something like this, right? Well, if we take a look at what these things are, you'll see these in the literature. They're really very simple to understand, actually. And what they are is they're ways of looking at values that are when you have more than one value and you want to take the measure of them. You get into like this situation, for example, with vectors. So you know how we typically have vectors, for example, in 3D, we have an XYZ vector. And oftentimes we've said, well, let's take the length of the vector. And what did we do when we took the length of the vector, right? What did we actually compute? Well, if you remember correctly, we essentially used the Pythagorean theorem to compute the length, right? If you imagine the triangle where we have, sort of the x and the y here, and we want this, right? This is our length. We said, well, the length squared equals x squared plus y squared, right? So when we said we wanted to figure out what the length was, we said, well, let's just square root both sides, and we have x squared plus y squared square rooted, right? And that's how we were computing the length of, say, our two-dimensional vectors. And three-dimensional vectors are the same. It was just plus z squared over here or whatever, right? So, right, you can trivially keep extending this outwards no matter what your dimensions are. It just gets longer. So that is actually the 2 norm. Right? That's actually what that is. The length, what we were taking here when we say length is actually the 2 norm. What do we mean by 2 norm? Well, the 2 actually refers to the power. Because the definition for a norm, generally speaking, is that the norm, whatever it is, when we say the n norm, what we mean is that it equals the nth root, whatever that is, of the components raised to that power, right? So the 2 norm is the square root of x squared plus y squared. The 1 norm would just be the values added together, right? Because it would be the first, it would be a non-square root, basically. It'd just be nothing there. X to the first plus y to the first. So it would just be x plus y. That'd be the 1 norm, right? The 3 norm would be the cube root of x cubed plus y cubed, right? And then the most mysterious one of them all, this one right here, which is the infinity norm, is the infinitive, whatever you want to call that, the infinite root of x to the infinity plus y to the infinity, ... And so let's talk about these real quick. So you're very familiar with the 2 norm already. That's just what we think of as Euclidean distance. That's the typical notion of distance in Euclidean space that we're all familiar with. That's the 2 norm. The 1 norm is just the sum. That's the sum total of all of the values, right? And you use the 1 norm often in computer graphics as well, because, for example, when you want to renormalize things like blend weights, right? You want to normalize the blending equation. Well, you need all the weights to sum to 1. So what do? You divide by the 1 norm. Add all up the values, divide by that. Now you know that everything sums to 1, right? So 1 norm, 2 norm, very common. 3 norm, not so much. Infinity norm, more common than you might think, because what happens when you take the infinite root of a sum of infinite powers? Well, the answer is that actually everything but the largest the largest variable drops out. So what this actually becomes is max x, y, z, ... So the maximum component of all of your components is the infinity norm. So if I had a vector and it was 9, 10, 3, and I said, what's the infinity norm? Well, the infinity norm is 10. Because it's 9 to the infinite power plus 10 to the infinite power plus 3 to the infinite power to the infinite root. Now, you would need somebody such as perhaps pseudonym 73 to explain to you the number theoretic basis by which that actually comes out to be the case. I don't pretend to be a math proofs kind of a fellow, so I am not even going to attempt to tell you about that. It is way out of my area of expertise. I can simply tell you that that is the definition of the infinity norm and leave it at that. Okay, so point being, what I was sort of speaking of when I sort of threw that as a side, and I thought it might be a good chance to sort of slip that in as a minor educational topic. So now that you know what people are talking about when they talk about norms, in here, when we're talking about taking something that expects to operate on one thing, and then we want it to operate on a number of things at the same time, but still only produce one output, right? If we wanted to have n copies of this operation, well, then we just have a for I loop, right? But in this case, we still only want, we only have one value that we're outputting. We're still just outputting one value for DDT Bob. So we need some way of actually rephrasing the equation in terms of multiple inputs, but only still produce one output. And one way of doing that, again, is using a norm on the input so that we're actually just summarizing the input down into something that's what we were originally working with, such as length. Instead of taking just the length of one thing, can we now say what is some other measure that would sort of make that work, right? And so in this case, I'm not sure, but let's say that that's what we were going to do. So imagine here we're going to say paired, entity index or something like this. And we would say paired entity index is less than paired entity count for the entity that we're on, and then we would increment that. Then we would look at which entity that was in the paired entities, and we would grab out our pair from that as a pointer. If there is something in that slot, meaning the slot is valid, then we could sort of do the same equations that we were doing here, right? Like so. And really the t-head distance, I suppose, could be clamped at the end. So it's only really the head distance part that we're doing here. And so we could make this head distance initialize to something, go through here, and sort of take the that length notion, and then at the end produce some final value. I'm going to go ahead and maybe just say let's take the 2 norm. Let's take that average. We already know that we're doing a length operation, so instead of square rooting, I'll just leave it squared. And then at the very end, I will square root it. So you can see what I'm doing there. I'm just I'm just summing all of those up, so that as we get them, I'm summing the squares. Just like the x squared, y squared, z squared, I'm doing basically the sum of the squares of the lengths. And then I square root those to get a final head distance. Then we go ahead and operate on it like so. And in this case, our head distance will be 0 if there were none. So we no longer really have to check separately to see if we had a head, because this loop is effectively that check, right? So here's the movement planted. Code now, if we did not know anything about what we might be paired with, and our rule for how we wanted our bounciness to work would go with that, essentially. So there you go. So that's the kind of thing that seems relatively reasonable. I don't know, again, I think it's maybe a little too soon to say for sure whether we need additional things there, but you can see that it would be relatively easy to write things in this fashion, because we can respond to an arbitrary number of attached entities at this point, and that's the kind of thing that we're going to be looking to do as much as possible, meaning can we generalize these things up into things that don't require specifics, that can work sort of more in generalities, so that as we get more permutations of stuff, they can interact with each other in a richer fashion. So if I go ahead and compile that, you'll notice that most of my troubles here now come from the fact that we no longer have that head entity to pack. And what you'll notice is when we're doing this packing, we don't really have the packing operation doesn't really do anything. It just does a block copy of the entity over into the sort of the raw space. And so one question that we obviously have now is, well, what do we want to do here during this packing in terms of packing down things like this array, right? The paired entity count part would still pass through just fine, but this part right here with the paired entity pointer, what we actually want to do is pack that array, however many entries there are, into the chunk, right? And so now might be a good time to start to think about that part of the process. There are 2 things that we care about here. One is that we pack and unpack this array properly, using only the amount of space that's necessary to hold the array, right? Because remember, we could get around this by just going like that, but the idea is that will eventually get too unwieldy. It's probably not too unwieldy right now, but as we up the number of entities and up the number of things in the entities, that amount of data throughput just gets more and more and more, and eventually might lead to constraints on what kind of gameplay we can have if we're not more judicious. So what we want to do is say, let's only pay for the entities with which we are actually paired. And so what we want to do here is say, just pack the number that's actually there. And that's a pretty easy thing to implement with what we've got right now. That wouldn't take much time to write. Now, what's a little bit trickier and something that we haven't really seen yet is what we want to do for essentially growing these arrays over time, right? Because what's going to happen is when you first create an entity, there might be no paired entities with it, and so this pointer could just be 0. Later on, you're going to add a paired entity, and maybe that's a time when you allocate a little thing temporarily in the sim region to store it, or whatever. But what's our policy there? How do we deal with that? We essentially now have this notion of a dynamically growing array, and we don't really have any way of dealing with that yet in the system. So how do we want to deal with that, right? What do we want to do? And what's our policy there? There's some, people do like you grow by 2x every time, or other things like this. For something like the paired entity list, I think it's unlikely that you're going to have a ton of paired entities all that often. So I feel like probably what we want to do is just allocate in like blocks of 4 or something, right? Because the chances of somebody having, 100 paired entities is fairly low. The chances of them having 0, 1, or 2 paired entities is pretty high. So we probably want to optimize for the more simple case there, right? All right. So let's write this code because, like I said, I think it's a good place to do that. So the first thing I want to do is I want to take pack entity into chunk. Oh, and by the way, this might be a good time as well. I think we've got about 20 minutes left on the stream here. This might be a good time as well to take a look and see if it's now a good time to move the unpack code over here into Handmade World. Because my goal is to have all of the pack and unpack stuff happening in Handmade World, and then all the sim stuff can happen over in sim region and entity. But I'd like the packing to kind of live in a place where we can see it very clearly what's involved in the packing and what's not, because that's a process we want to sort of systematize and not screw up. Excuse me. All right. So here is our problem child. Pack entity reference head is now an arbitrary number of things that we need to pack. Again, not particularly difficult. We know we have to pack some number of entity references. Now, what's an entity reference? Well, an entity reference is actually a pointer and an index, but guess what? If we're going to start packing these things, we actually don't need to pack the index anymore, right? And so what we can start doing here is saying, well, we really don't need entity reference anymore, right? That's not really a thing. We can just store entity IDs by themselves. And so, you know, when we pack, we could leave the IDs in here if we want to carry the IDs through, and there might be some valid reasons why we might want to do that. I'm not 100% sure that we will ever need to do that, but basically the reason that we might need to have that notion is we might need to have entity IDs be things that you can look up and keep even if if they're not nearby, right? Because remember, the only things that get translated into pointers are entities that are actually nearby. So we may want to start to sort of break that notion, right? And so if you have an entity reference, you know, we may want to make it so that I'm trying to think of how we want to do this exactly. I guess here's the general problem. If people ever want to keep track of an entity long term, meaning, let's say, you know, this would not be anything that's frame to frame simulation, but let's say we wanted something to remember a thing like, I am looking for some special gemstone that's created in the world, and so my entity has the entity ID of that gemstone in it. Right, perfectly standard thing. So that I would know if the gemstone were nearby to me or I saw it, I go, that's the gemstone I'm looking for. I could match the IDs or something. I don't know, I'm just making this up. Another one would be like, oh, I have a familiar, and if I'm on the same screen as the familiar comes over to me and hangs out. If I'm off somewhere else, I don't want the familiar to forget that they're my familiar. When I come back on, I want them to recognize me again and come over, right? So that's really what I'm talking about here. So the way that we have the system set up right now, you couldn't really do that, because as soon as the person goes out of simulation range, it would forget that you were ever, that ID would go to 0. That's just the way that it works right now. And so I suspect that what we would rather have is we'd rather have the ability to store entity IDs permanently over time. Now the problem with that is how do we make it clear in the paired entities that that's what's going on, right? And we have a couple different options. So one is we always keep the entity reference around, where we have the entity pointer and the entity ID, that's the index, right? And then whenever you set it, if you set the entity pointer, you have to set the entity index as well, right? Because if you didn't do that, then we would never know when we go to pack it. What we would see is the pointer was set to something and the index was set to something else, right? In the case where the pointer was set to something valid, we would know to overwrite the index with that entity, that pointer's entity ID. No problem. In the case where the index wasn't, where the pointer wasn't valid, right? And just to be clear, I'm saying, let's say we did this, right? In the case where it wasn't, so the pointer is 0, we wouldn't know whether that meant clear out the index because this person's no longer looking at something, or if that just meant, oh, when we loaded this guy in, the entity index that he was looking for doesn't exist in this sim region. So we couldn't find it, right? And I don't know, right? Because I could see it doing either way. But, I mean, I guess what I'm saying is at a bare minimum, we've got to do at least this or that, right? Where we only just ever keep track of the index. But if we kept track of both of them, so you can quickly use the pointer and you don't have to go through any kind of a hash table to use the index. So if you went this route with it, then I guess what we could do is at pack time, we could say, oh, is the index, this entity's index that we have here, is that in the hash table? And if it is in the hash table, then it's okay, right? If it's not in the hash table, then it's not. And I don't know. There's a lot of cons with that too. The entity pointer will appear to be 0, so everyone who's using an entity pointer will not get one, right? But the ID will still secretly be valid. So if someone wants to say, am I chasing anyone? The thing where you do like if entity reference.pointer is not right, because it's really entity.index that tells you that, because the pointer might be 0 if the person just doesn't happen to be in any sort of simulation range that you can see. So you can see why this is relatively complicated. But I do think there's at least some merit to essentially saying something like this. Let's say that we made this structure 16 bytes long. So we essentially said, we've got a relationship, we have an index, we have a pointer. That's what an entity reference is. You always use the pointer anytime you're trying to do something, but you always check the index if you're trying to figure out something is correct or not. And we could say, well, let's go ahead and make these extra hard to access so that people know that they really should not be accessing them. And then we can make it so that you're supposed to go through some helper functions that do the right thing, right? I don't know. You can see why this is complex, right? It's a tricky bit. It's easy to implement no matter what we pick to do. The problem is just I want to make something that's not going to cause too many problems for the usage code. And I think most of the time the pointer stuff would just work, but I'm just worried about that one case where the pointer's null but the index is still valid, which is the case for long distance references, essentially. And I just don't know if there's any other way I can really make that be any more good, right? So I'm just not sure. Another option would be to make the entity always point to some kind of a special dummy entity, and you can test for that. I don't really love that either. In short, I just don't think there's a lot of good stuff to do here, other than maybe try to have some helper functions that make it easy to do the right thing. But it's basically a tri-state condition, right? It's something that looks like this. It's like 0, no reference. 1 is reference to something in sim range, and 2 is reference to something out of sim range. So basically everyone in the game who is using entity references for things is going to have to know whenever they do processing on that reference, they need to expect one of those 3 states, not just 2 states. Because normally it would just be like that, right? That's what we would have in the simple case where we didn't support essentially out-of-course sized worlds, which is sort of what we do support now. I don't know. I just don't know. I just don't know. Don't know. So yeah. I guess what I'll say about that is I guess we'll sort of have to see what the code breaks down to look like. If I was to look at the one piece of code that we started with just now and say, what does that look like, right? Then you can see this code right here. This code probably just is fine, meaning it's not making any decisions about this. It's just saying, hey, any entities that actually are available to me, you know, right now, I will go ahead and take their lengths, and that'll be that. Right? And so it would work fine, and I guess maybe the answer is just, you know, maybe really what we want is it's just you almost always use the pointer, and you only have to worry about the index if you're talking about something that you're about to like you're about to make a decision about it based on whether there is anything there. And maybe there's a thing that's like B32, you know, reference exists or something. I don't know. Or reference is valid. Reference, I don't know. Something like that. And it passes the entity reference so that you can always ask, you know, hey, tell me, is this thing valid? And that'll always look at just the index. It's never going to look at the pointer, because the pointer is irrelevant. If the pointer is 0, it still could mean that the index was valid, in which case this reference is still valid. So something like that, right? So let's say that that was the case. I'm going to go ahead and compile this. What did I do wrong? Oh, right. It's index.value. There we go. So let's get back to what I was talking about before. So when I want to store these things, and I may go ahead and also do, now that I think about it, I may do a slight switcheroo here as well and say, let's have like an entity stored reference. So, you know, this is like that. Something like this. And that way, when we say, hey, are 2 references equal, we could also have a thing that's like, hey, inline B32. Something like references are equal, and we say entity reference A, entity reference B, which is a little confusing because it's hard to say whether that should include the relationship or not. But that, I guess, will be something we'll have to think about a little bit more down the line, right? But OK. So in here, we would say, if references are equal, we'd say, yeah, we'd just say entity stored index equals B stored index, like so. I don't know why that was a bracket. So, we've got a check on that. We could also demand that A stored relationship equals B stored relationship. And yeah, then here we just say references are equal. I guess, I might keep the pointer around. In this case, maybe even in the other case. Because, we really don't know. The person may have set and not set the index yet. So I'm just trying to think of how I would like that case to proceed. Let's say I set the entity reference and didn't set the index yet. Just set the pointer. Yeah, so I think that's actually what we want. I think we want to say references are equal a.entity, b.entity. Something more like that. Okay. So now when we do our packing, we've got sort of our pack entity into chunk. What we're going to do here is we're going to make sure that our indices are packed properly. And I guess I'm kind of running out of time, unfortunately. That's unfortunate. So now what I want to do is say, okay, let's do a pack entity reference. What I want to do is say, how much room am I going to need for the array of this particular fellow, right? Of this particular entity. And so we know that we will need to store a paired entity count of them, right? So our pack size is the size of the source plus some data, right? However many paired entities there are times the size of the stored entity reference. Right? So that's how we actually would compute how much room we need now, which is more than just the room for the entity itself. So now when we get down here and we say, oh, we've packed this this source in here, we now also have to pack where we pack the two traversable references, obviously. We now need to pack this entity reference array, right? And so what we want to do is we want to do pack entity reference, the array of entity references. Pack entity reference really doesn't probably need to be a thing in quite that way anymore. We can probably just bring it down here and say, all right, let's pack all these things together, right? I'm a little nervous about not having name slots for these. Maybe it's dumb to have them in an array and not to have them named. But I just don't know how else we would support things that kind of have arbitrary numbers of things that connect to them. And we can always have more than one array if we want, right? In fact, what I could do here is I could actually call this, I could leave it outside and say pack entity reference array, right? And then, just say the reference count, or even just count, we know what it is. There's the source, right? And then stored entity reference. Why is that entity stored reference? Should be stored entity reference. And then we'd say stored entity reference destination. Then after we loop over these, we'd say, all right, the dest, we're going to do exactly the same thing we were doing here, right? we'd say the destination index is going to equal the source's pointer's ID, but only if the source's pointer's ID is not equal to 0. So only in the case where, where the source pointer is not equal to 0. So only in the case where we had a valid pointer do we want it to be equal. But we're going to expand this case a little bit and say, well, if it was equal, then, maybe we're going to do this the other way, where we'd say, like, we'd still preserve that ID. Maybe we'd do that, and we'll do that if it's in the hash table, right? So this is going to have to this is essentially going to need to know the sim region information. And this, I guess this sort of begs the question too now of, does the packing live in the sim region actually instead of over here in the world? Maybe this world thing, will literally just be for, will not, you get the idea. You know what I'm saying. Because we need that hash table to know whether or not we would repack this, right? And so, yeah. I mean, the other thing we can do is do that at when the sim end closes down. But I don't know to what extent we really want that to happen. It just seems like a little bit of overlapping work there. So anyway, point being, we're going to have to do this case. I'll leave it for now. Oops. But instead, I guess what I'll do here is say, okay, we'll clear it in that case. In either case, we'll say that the relationship, well, I guess, no, that's probably not true. We'll say that the relationship equals the source relationship. And in this case, I guess we'll say none. Right? And we'll increment the 2. So we walk the array, and we just basically remap those the source over to the dest, and then we're done. We could also do this. So at least we know it's always initialized, and then in here it's like we could just see if the hash table, if it's found. All right. And so then what we would need to do here is we wanted to pack these entity references in. All we have to do now is say, well, okay, we know how many there are, right? We know the dest entity. We know in the source entity, we know we've got that that entity, that paired entity count, right? And then we know that the source's paired entities is the array that we're coming from. And then finally, we know that the dest is the amount that we added, right, in our pack size that's after the source. We know where that is as well. And we're going to want to make this a little more systemic, but we know exactly where the entity stored references live as well. They live out here. So that's the packing code. And we're over time, so I gotta wind it down here, but you see where I'm going with this. This is all pretty straightforward, right? Let's fix that with the dot value. Pack traversable reference. So a traversable reference, I guess, is really just this, though, right? And this is really something we want to do. Yeah, I don't really want to. I want to do this fairly correctly. So I really don't actually want to wind down right now, which is kind of annoying. Well, I guess I'll do the minimum to leave it in a compiling state, and then we'll move on. Let's just say that. This is actually stored entity reference. paired entity count, paired entities, identifier not found, pack entity reference array. We have our load entity reference. And then we have our head happening here. When we add the player, at this point, yeah, we're going to need to be able to make that array do its thing, which is actually relatively simple in this case, right? Because since in both cases we just have one of these, we can do an entity reference, which is like body refs 1, entity reference head refs 1. Right? And then in here we can just say like, oh, okay, the body paired entities equals body refs head paired entities equals head refs. Yeah. So body refs 0 dot pointer equals head refs 0 dot pointer equals body, and off you go. And in both cases, paired entity count equals 1, head paired entity count equals 1. Right? So there you go. And in this case, we can just do re-enable, and we'll say that the body just doesn't exist at the moment. Same here. Okay. And this code we actually could have done before. The head delta, obviously, is just the distance between whatever that paired entity is and our entity. So that's fine. So yeah, I think at this point we probably would have a bunch of bugs that we're going to have to deal with, and we haven't implemented half of the things, but I'm going to leave it there so we can go to Q&A. Let's go ahead and do that now. And I'm not sure, yeah, like I said, I'm not 100% sure whether I like the flexible array thing or not, but we'll see. And SZ, a fairly simple way to describe or understand the infinity norm is to draw the unit hyperspheres for each of those common norms. The 1 norm would be a diamond shape, the 2 norm is the regular circle hypersphere, the 3 norm gets more squarish, hypercubish, and so on. You'd quickly see that this series converges towards a square/hypercube. I don't know that that's a fairly simple way to describe or understand the infinity norm, because first the people would have to understand the mapping of it to the sphere. But yeah, I mean, I can see that. Fliadelsky, have you seen Scott Meyer's talk on CPU caches? Lesson 1 of programming is don't listen to a Scott Meyer's talk. He talks about how it's better to store data of the same type together in memory because they end up on the same cache line, which is good for performance. Is this something that you think about or will cover in Handmade Hero? So that's not true, right? Obviously, that's not correct. The true statement is that it depends how you're processing it. You don't want to keep data of the same type together in memory. You want to keep data that is accessed together in memory, right? So if you're accessing A, B, and C always together, but they happen to be completely different types, those you want to put close together. You know, if just because I have, say, 1,000 x coordinates, but I never bulk process my x coordinates, there's no point in keeping them close together. That's like worse, right? Spatial locality is just about keeping data that is used together close together. And sometimes you have to make concessions to SIMD, where you're forced to process data in a bulk fashion because of the way the floating point unit works, and that can be true. But that is an aspect of the fact that the algorithm worked that way, not that it is better to keep things. It's still because you're accessing them together. And SIMD forces you to process things in same size bulk like that, because you don't want to transform, right? So no, like if that's what he said, that's just wrong. But he may have said the right thing and maybe just wasn't clear about it or whatever. But yes, we've covered that on Handmade Hero many times. It's not something you typically think about until later in your architecture, because it's something that causes a lot of cost if you're constantly trying to do it, and most of your code doesn't need it. So you have to be judicious in knowing about when you care about that. Part of that is C++'s fault. C++ is awful at data organization. It has almost no utilities. It has almost no features that allow you to organize your data well. If you've ever watched John Blow's stream on JAI, you can see that he's already got some nice features for that, where you can twist the way things are stored without having to rewrite the code, so that you can pick better orientations of them for things like spatial locality. Could you use the entity pairing concept for a vehicle-occupant relationship like an airship and its passengers? And if so, how would movement work on it? In our system, probably not at the moment, because we already have the concept of standing on. So you would probably just put standing on. You would probably just have them standing on the traversable points that are on the airship. Stevoid 1990. I was just wondering why you don't have a subscriber button for those that enjoy your frequent broadcasts. From what I gather, you were offered partnership but turned it down due to something in the contract. Can you tell me a little why you made that decision, and what options do you have to donate? Sure, yes. So first of all, if you do look down in below the video in the Twitch information, there are a bunch of links. But if you just want to remember one thing, you can go to handmadehero.org. And we have both a Patreon and a way to pre-order the game. So if you're looking for to support the series, both of those are much appreciated. Either one or both, or whichever one, whatever you want to do, is up there on handmadehero.org, certainly. So yeah, that's what we've got. As far as the information you were asking regarding Twitch, yes, their standard contract has some things that we can't sign, such as a prohibition on uploading the videos to YouTube until a certain amount of time has passed, and various other things like this. And since a lot of people watch the series very regularly and watch it almost immediately after it's broadcast, maybe within an hour or two on YouTube, I did not want to disadvantage those people who cannot watch the stream live and make them wait extra days to get it, potentially due to a contract with Twitch. I did try to go back and forth on the contract a couple of times, but we kind of got a few terms ironed out, and there was a couple things left, and then they just stopped ever writing me back. So I guess they didn't care. So I've never heard from them. I emailed them like 3 times after that. So I tried to get it set up because people wanted it. I seriously sent them like 3 mails, like a couple weeks apart, just being like, what, how come I've never heard back about this? Like, what's the deal? And they just never talked to me again. So that's the last I ever heard of them, was a month and a half ago or whatever. They didn't ever actually come say no. They just stopped talking to me, which, I don't know, was kind of rude actually, but I mean, I don't really care because it's not something we need for the series in any particular way. So yeah, that's the situation. In general, like I said, that's not really a problem. It's not something I really wanted. I don't mind that Twitch didn't want to do it, and their contract is their business. People had been asking for a subscribe button, so I figured I might as well spend the time it took to read through their contracts and see if it was something we could sign up for. It's not a particularly good or even useful deal for us. Supporting us via Patreon or supporting us with by pre-ordering the game is way better for us, and it's way better for you because you get the source code to the games to play around with at home if you pre-order the game. So I would say it really is no big loss not having that subscriber button. And if you just want there to not be ads on this video, I don't play the ads. I never play any ads on Handmade Hero ever, but Twitch inserts them at the beginning, I think. And if you don't want that, you can go to get Twitch Turbo or whatever. So you can subscribe to Twitch separately, and then you won't see ads on the channel anymore. So you can, give them some money in exchange for that. So that's the full. That's, as far as I know it, that's the full story. Guitar, is it not possible to subscribe to forum posts anymore now since the new stuff was made? I don't get any posts to my mail. I don't know. I am not really involved in the forum software at all. So you can ask them about it if you'd like. There's, obviously, if you go to handmadenetwork.com, there's a forums for Handmade Network where you can post feature requests or ask why something's not there. That's all I can tell you. And yeah, Omni Technomancer is saying subscribe doesn't make it ad-free anymore. Twitch Turbo makes it ad-free, at least it does for me. And ad-free might not be true. It gets rid of like the ads at the beginnings of anyone's stream. I subscribe to Twitch Turbo, and I've never seen an ad on like Sean's stream or John's stream or anything. So it got rid of all the ads that I had ever saw. Now, whether if it's on some big, super important stream of like, Dota special tournament something or other, then I don't know if that, maybe they still throw ads in that, I don't know. But on everything else, it got rid of it. Whether subscribing to a particular channel gets rid of the ads, that I don't know. That might not. So I would say if you're looking to get rid of ads, go Twitch Turbo. I can pretty much guarantee you that at least right now, you won't see any ads on Handmade Hero, because I don't run any. Now, other channels who try to make money off of their stream, they run ads specifically on the stream. And so maybe that, is a thing. But for watching Handmade Hero without ads, I never run any ads on it, and I never put any ads on our YouTube. We are completely ad-free, and we generate no revenue from the streams or from the YouTube ever. And so if you, unfortunately, Twitch doesn't allow me to say don't ever run ads on my content, which honestly is one reason I'd probably like to not be on Twitch anymore at some point. I'd rather be on an ad-free service if there was one. I don't know if there is. But since I don't make any money from it, I have no incentive to run those ads, and I don't want you to have to see ads. So, there's not much I can do about that. Are we done with the cues? Oh, no, we're not. There's one up here. This entity reference stuff feels premature to me since I don't think we have a lot of examples of how it will be used. Are you doing it now for a particular reason? Yes. So I'm doing it now because, well, obviously the entity reference stuff, I assume you mean the entity reference array, not the entity references, because we already did a bunch of entity references. So the reason I'm doing it now is I need some system in there to start playing with the concept that I don't know exactly what input I have. Because right now I've been leaning on the fact that I have an entity type, and the entity type just knows, oh, I'm going to use like a head pointer or something, right? But I want to start trying to write some code that doesn't really know. So like, the example would be, I don't know how many legs I have, right? Like maybe there's just legs sticking on me, and I know that I want them to kind of like wobble when I walk, but I don't know how many there are. And so I want to start having a way of like, being able to say like entities, when we say that I have a reference to an entity, I actually mean I have a set of references, right? And I suspect that I'm going to want to play with that a little bit. So I want to try it here with something that only ever really has one, just to see how it looks if I'm sort of doing discovery. and then I'm going to add more and see what happens. And I suspect I'm going to have to like fuss with it a little till it feels right. My suspicion is what I'm probably going to have is more than one array. So like the relationship part, where it's what the relationship of the entity was, I think that might be a mistake. So we'll see. But I got to try both. I don't know. We'll see what happens when I actually play with it. But I'm suspecting that I probably want to iterate over the like a couple different arrays, like or something, but I don't know. I really don't. I have no idea. So I'm just going to play with it. But I need at least one array example first to try, if that makes sense. All right, so it looks like we're good. I don't see any other questions that I need to address. So I'm going to close down. All right, thank you everyone for joining for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to play around with the source code at home, you can always pre-order the game on handmadehero.org, and it comes with the source code so that you can, play around with it. There's also a forum site if you want to ask questions. There's a Patreon page if you want to support the video series. There's a schedule bot if you want to know when the series is going to be live. And there's a episode guide if you want to catch up with past episodes. That's about it for today. We'll be back here not tomorrow, but Friday for the last stream of the week at 5 p.m. Pacific Daylight Time. Hope to see you there. Until then, have fun programming, and I will see you guys on the internet.